This is 2016 number 4, a non-calculator question. It says consider the differential equation dy dx equals y squared over x minus 1. We haven't learned slope fields yet, so we will not be able to answer that. And actually, neither of these parts we will be able to answer as well, so you don't have to worry about those. All of these will come at second semester. We can answer a few pieces of this one, which is 2016 number 5, also a non-calculator question. It says the inside of a funnel of height 10 inches has a circular cross-section. That just means that as it goes down, you get circles the entire time. As shown in the figure above, at height h, the radius of the funnel is given by this function, r equals, and then it gives you that function, where height of the funnel again is 10 inches. It says the units of r and h are in inches. Perfect. A, find the average value of the radius of the funnel. We don't know how to do that part yet. Skip it. Part B, find the volume of the funnel. We don't know how to do that yet. Skip it. Part C, the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. Anytime you see that word rate, you should have a little red flag going in your mind that says rate of change. It says at this instant, what is the rate of change of the height of the liquid with respect to time? All right, beautiful. So this is a related rates problem. We know that we have a couple different variables. We know that the height is 3. We know that the radius is decreasing, so dr dt. The radius is decreasing at a rate of 1/5, negative 1/5 inch per second. And I think that's all that we are given. We are looking for, at this instant, what is the rate of change of the height? So what is dh dt with respect to time? So we have our givens. We have what we're looking for. We even have a function that relates all those things together. So we have r equals 1/20 times 3 plus h squared. So we have a function that relates r and h. So we need to find the derivative of this, plug in what we know, and then solve for dh dt. So r, the derivative of r is dr dt. 1/20 is a constant, so I'm actually going to distribute it to both of these first before we take the derivative. So that's 3/20 plus 1/20 h squared. Now this 3/20ths is a constant, and I'm no longer multiplying, I'm actually adding, so the derivative of a constant is 0, so that 3/20ths is going to go away. For this piece of it, 1/20 is a constant multiple, since I'm multiplying it, it will tag along for the ride. The derivative of h squared is 2h, and then with respect to t, it's dh dt. So if I plug in what I know that dr dt is negative 1/5. I know that h is 3, and I'm solving for dh dt. So at this point, it has simply become an algebra problem. So I have negative 1/5 equals 1/20 times 2 is 2/20, that's 1/10, times 3. That's negative 1/5 equals 3/10 dh dt. Oops, sorry, it's off the bottom over here. And then if I multiply the reciprocal on both sides, I get multiplying by 10/3. So times 10/3 times 10/3. So this is dh dt equals negative 10/15. And negative 10/15 simplifies to negative 2/3. And don't forget to include units, inches per second. Negative 2/3 inch per second. And that is worth 3 points. 3 points on the AP exam.